My name is Michael Gratzel and I'm a professor at the École Polytechnique Fédérale de Lausanne. And I'm working on systems that mimic photosynthesis to produce fuels and electricity from sunlight. The oil crisis in the 70s, I realized that there wasn't all that much oil left. I was passionate about finding systems that would produce fuels from light or electricity from light.
It took kind of a stroke of genius. We call this the Gratzel genius, sort of.
The dye-sensitized solar cells are much closer to the natural photosynthetic system than silicon p-n junction solar cells. They use a molecular dye, a chromophore, a pigment, to absorb sunlight. And then the molecule produces electric charges.
So the construction of the Gratzel cell goes like following. We have a piece of glass, titanium oxide, coated with the dye. There's a second piece of conducting glass to complete the device. Electrolyte that completes the electrical circuit. Electron is generated inside the titanium oxide, goes through the electrical circuit. Electrolyte brings back the electron to the dye who lost it previously. That's how the cycle works.
It took about 10 years of work to ascertain that what we had in our hand was rugged and could be made into a practical system that the world could use. This technology offers advantages compared to the silicon cells. They collect light from both sides, very important in the desert because the panels will be vertically mounted. They collect very well the diffuse radiation. They can be used indoors. They are unbeatable indoors. They have much higher efficiency in the ambient condition indoors than the silicon cells.
And there's the big market of the building integration, transparent, aesthetic, nice looking. It's like art part, not only solar, but it has an aesthetic function. And now there's a new hope coming in with what's called a perovskite cell, which is a derivation of the dye-sensitized cell. And there the hope is to get a very high efficiency at super low cost, as there's a very small amount of materials involved. The legacy is that he has kind of initiated this avalanche of development in that field and made many thousands of young scientists to work with enthusiasm, with this promise of solar energy helping the world.
It's a huge success for all the people that have helped. It should be a good encouragement for the young people to pick that up and follow similar strategies, similar ways.